In this lesson, we're going to review the basic principles of object-oriented. So if you feel comfortable about these basic principles, you can skip this lesson to lesson 6, in which we discuss and explain how we can implement object-oriented applications in Java. The traditional way of implementing software programs in which we linearly execute code one after each other may work for small applications when there are probably a few hundred lines of code. But if we're dealing with a modern application and the size of the application in terms of lines of code are significantly higher, this structured programming or even functional programming may not be a very well model to organize our program. When I talk about size in terms of line of codes, these are some of the examples of well-known software applications. As you can see, this is the number of million lines of code. For example, Microsoft Office 2013 has something around 45 million lines of code, and it's not even the latest version of Microsoft Office. And for example, Windows Vista is around 50 million lines of code, or Mac OS Tiger is about something close to 90 million lines of code. And again, these are not the latest version of the software applications. I'm recording this video in April 2020, in the middle of the COVID-19 outbreak. So as we can see, when you deal with this magnitude of software applications, it's not that easy to just start writing code from top to bottom and just write, for example, 50 million line of code. Even if you are applying functional programming in which you package your code into multiple functions and the execution of the code is where each function calls another function, still that result is a significantly difficult type of application when you want to first implement it, when you want to test it, when you want to change it, maintain it, and etc. It would be a nightmare. In order to implement these type of complicated applications, we cannot rely on a structured or functional programming. And as such, software developers started looking for a better way to manage and structure their code. And from 1990s, the concept of object-oriented programming has started gaining lots of attention, and it has become the primary principle of software development. And ever since, it has evolved significantly. So most of the software applications that you see today, they have been implemented via an object-oriented programming. So what is object-oriented programming? Well, if you look around yourself, for example, if you're sitting right now in your room and watching this video, look around yourself. What you see, for example, you have a bed, you have a table, you have a computer that you put it on your table or on your desk, you have a wardrobe, and etc. These are all different entities that are inside your room that basically form your room. Each of these entities, they provide a service. They provide some sort of functionalities to you as a user. For example, your computer provides a bunch of services for you. So the concept of object-oriented programming is very similar. It's to code software applications and structure software applications in the way that we as humans see them, and basically we want to model these similar entities, or as we call them in object-oriented terms, objects, in our application. So our application becomes the implementation the first identification and then implementation of these entities in the context of the application, and then these entities start talking to each other by requesting services from each other, and that's how the software eventually operates, and that's called message passing. So what is a class and object? So as I mentioned, an object is an entity that you have in your system. Like in a student management system, we have different entities. We have students, we have lecturers, we have classrooms, we have courses, we have a timetable. These are all different entities that we have, and we can model them and we can implement them in our software basically platform. These are called objects. A class is a template that we consider for an object. For example, we can have a class for a student. It's a template for all students in that system. And what it does, it contains attributes or data fields or information that you want to store about about the students in your system, and also bunch of operations or services that a student performs for others. So a class is a template for all these students. So basically, we list all the data operations, data fields, and operations or attributes or properties and behaviors, methods, or procedures in the context of this entity in our system, and we label that as a class. For example, we labeled it student. And then an object becomes an instance of that student class. In a typical hospital management system, we have these two typical classes, a patient and appointment. These are the list of attributes. They are pieces of information that we want to basically store in the context of patient, like name, birth date, address, phone number. Bunch of operations that the system needs to perform in response to patient. For example, we can request to insert a new patient into the system or delete a new patient in the system. And similar, another class, appointment. We will say that an appointment needs to have the patient name, the doctor's name, a date and time, and the operation that we can perform, inserting of an new appointment or deleting of an old appointment. So these are templates. They don't present any actual appointment entry, or they don't, or this patient class doesn't represent any actual patient. When we instantiate it, that means when we create an actual entity of this patient with information, then we have an object. For example, here we have a patient. This is the object name of type patient class. So this a patient is the representation of this, is an object of this class. And now it has a name, a birthday, an address. So this is an actual instance of this class. We call that an object. And same for an appointment. This is an actual appointment because we have values, we have the actual data for these different pieces of information, like patient's name, doctor's name, and etc. So a class is a template. Objects are actual entities in our system. The way that an object operating system operates is by objects requesting services from each other. And that's via sending a message from one object to another to perform an operation. And as I explained, it's called message passing. What is abstraction? Suppose you're designing or implementing a retail application. And in that retail application, you're supposed to sell computer products. When you want to design the class for computer products or for products, there are different type of information that you need to consider. For example, if I want to purchase a computer, the information that I look at are, for example, what is the brand, what is the color of the computer, if it's for example a notebook, whether it's touch screen, what is the processor, what is the HDD, what is the RAM capacity, and also the price. So these are all the different pieces of information that you need to consider when you design a computer product class in your retail application. Now consider another application, a shipping application, and that shipping application also need to consider the same product. For a shipping application, some of these information that we discussed, for example, whether the computer is touchscreen, what is the CPU in the computer, what's the color of the computer, these are irrelevant. Instead, there are other information that's important. For example, what is the dimension of the package, what is the weight of the package, and etc. So this is called abstraction. Basically, what it tells is objects only include the information that is relevant in the context of the application. When I want to purchase a computer, the size of the package is probably not a very important piece of information. But that same piece of information is very important for a shipping company. So with abstraction, we said that when we declare the classes, when we want to design the object templates, we only include the information that is relevant to the context of the application and ignore anything and also any functionality of the object that is irrelevant to that application. Information hiding. In the student management system, we have this entity called lecturer. And one of a lecturer's responsibility is to mark assignment. As a student, you complete your assignment, then you submit your assignment to the system. The system notifies the lecturer via message passing that a student X has submitted assignment, and in response to that message, the lecturer object invokes a function mark assignment. Now, as a student, you're not concerned whether I mark your assignment at my home or at my office, whether I use my personal computer to submit your mark or I use my tablet to submit your mark, whether I mark your assignment at 4 in the morning or 8 in the afternoon. All you want to know is the result of the marking operation, that's your mark, and probably with some feedback. How, as a lecturer, I implement and perform the marking is something that you're not concerned. That is called information hiding. So in object-oriented terms, when we identify and put the information and functionalities in the context of the class inside the box, and we close the box, we encapsulate information and functionality, and we label it with a class name like lecturer or student, we are hiding the content, the internal content of the class. And as a user of the class, for example, as a student, all you need to know is that these are the services that are publicly as a lecturer advertised for you, and you can request me to perform them for you. How it's been done, you're not concerned about that. This is called information hiding, and it's a very important concept in object-oriented programming. The main reason that we want to hide the internal functionalities of objects is because we want them to be as independent as possible. Why do we want them to be independent? Because down the track, when we want to change that, for example, we want to change the old lecturer class with a new lecturer class. All we want to do is just to take out the previous lecturer class and replace it with the new one. And we want the software to continue its operation with minimum changes that we want to perform. This is called minimizing coupling. That means the changes that we make to a class, we want the side effect of that change to be as minimum as possible, so we can continuously keep changing software applications. And that's where the concept of modularity also comes in place. Modularity means you have for example, a complex system. You break down that system into hopefully independent modules, in which you can take out the module and replace it with another module that performs the similar type of operation. And we expect the software to be, or the system to be able to work. So in an object-oriented setup, all we want to do is to identify what are the classes, what are the information and the operations for those classes, implement them, and then we want to assemble the software by putting these classes and objects together, and we want them to be able to work. The next important concept is inheritance. There are many situations that we have similar classes in our system in which they share multiple characteristics and operations, but they also have their own specified operations and pieces of information and data. If that's the case, we can use inheritance to design a superclass or a parent class and put in all those common operations and characteristics, and then we can create child classes or subclasses that inherit from the superclass all those common operations. Look at this example. Suppose we have these two classes in our system, a patient and a doctor class. As you can see, both of these classes, they have common characteristics and operations. For example, both of them have last name, first name, and birthday, and both of them have this function update birthday. But they also have a specific attributes, for example, insurance carrier for patients and medical school, and also specialty for doctors. If that's the case, we can use inheritance to design this superclass, and let's say we name the superclass a person. We put in all the common operations and attributes, like here, and then we declare patient and doctors as subclasses of person. In this case, we say that patient and doctor are children of person, and they inherit all these common properties and operations, providing that we declare them in a way to be available for inheritance. We'll discuss that later in the next lesson. So that means patient inherits last name, first name, and birthday, and update birthday. It's like that we have them here. So inheritance gives us a way to avoid duplication and have a better structure for our objects and classes. This is another example. We have person as a superclass, doctor as a child class, and also patient as a child class of person. Doctor is also a parent of two other classes, a general practitioner or a specialist. That means a person can be a doctor and a doctor can be a GP or a specialist. Now we have the concept of abstract classes and concrete classes. With an abstract class, we mark the system in a way that we basically tell the system that this class is not available to become an object. That means we cannot have a direct object of person. This class is only available for inheritance. So in this system, an object can be a concrete class. That means we can have patient objects, we can have specialist objects, we can have JP objects, but we can have person objects or doctor's objects. So all we need to do is to mark these classes that are only available for inheritance but not instantiation as abstract. Polymorphism means the ability to take more than one form. Look at this inheritance relationship. We have a superclass transportation and we have three child classes, car, airplane, or cruise ship. So all these classes, they implement the same functionality. They basically transport. But the way that implement that functionality is different. The way that car transports or an airplane transport or a cruise ship transport is different. So this is called polymorphism. In an inheritance association, we basically can have child classes that perform the same operation, but they implement it in a different way. And with polymorphism, it's the ability to hide these different implementations behind the same interface. So it means that different objects can take different shapes. And finally, aggregation. If you recall from the first example that I used, when I refer to you and ask you to look around you in your room and identify what sort of entities or objects surrounded you, we mentioned, for example, a desk, a bed, a drawer, etc. if you're sitting in your room. So aggregation is a type of relationship when a bigger class is composed of multiple other classes. For example, in our analogy, the class bedroom is composed of a desk, a bed, a window, etc. Or for example, a car object can composed of an engine object, wheels object, transmission objects, etc. And even each of these other objects can compose of other objects. When we have this type of relationship between multiple classes, when a class is composed of multiple other classes, we call that relationship, or in object-oriented terms, this association and aggregation association. So this was only a quick introduction to object-oriented programming. In the next lesson, we explore how we can implement these different concepts in Java. Until then, happy learning.